Hey, this is John from Gadion. Today I'm going to be reviewing a few books on topics related to machine learning. So this will include a couple books on the actual coding side of things, and mostly some math books though. So I think the way I'm going to start doing this going forward is, I will have some videos on specific books if I think it's important to dedicate a video to one book, but otherwise I'm just never gonna actually get through a lot of the other books that I should be getting to review in the future. So we're just gonna do them as bulk. So first one first, Machine Learning with Python Cookbook by Kyle Gallant and Chris Albon. This is the only one I actually didn't grab the table of contents for, and it's also the only one without writing. The big problem, I think, so I guess, is the book okay? Is it bad? It's a good reference material, otherwise it's just not very useful. And even the, qualities of reference material can really be put into question. And it's not because of the book itself, it's because of the fact that it's written in that cookbook style. So you'll see what I mean in a minute, but there are some useful parts of the book. So, for example, the first 3 or so chapters are dedicated to like feature engineering and like general data analysis and cleaning, which is good because those are all things like, for example, the fact that you can call on ilocate or iloc in Python is never going to change. But a lot of these other functions, say over here, and we'll kind of go through what I mean in a second, a lot of these are going to change. So then, say you wanted to create a pipeline as such with cross-validation, say 2 years from today, this might end up being not completely useless, but the code will produce errors for any number of reasons. So it's better, I think, to focus on more fundamental aspects of programming aside from just, like these recipe type schemas. So anyways, here's a snapshot though from the slicing section. Here's a snapshot of like one of those cookbook segments, and unfortunately a lot of the book is dedicated to this. So what I mean by that, by the way, are these basically the way that a lot of especially in Python, a lot of these books are written like calling on objects that have already been created, which is kind of okay. I just don't see a reason to read a book about that though. So for example, up here we call on, from scikit-learn.pipeline import make_pipeline, right? And then, you also importantly take the standard scalar and the logistic regression from here, which you can see we're literally just, taking from the module and then importing that object from the module as the object, right? And you see that we do that, standardizer equals standard scalar. Okay, we imported the standard scalar. Logic equals logistic regression. We imported logistic regression. Pipeline equals make_pipeline, and then we import we give our parameters that we also imported into the imported pipeline. So I just feel that this is a very forgettable way to learn how to program, and it's going to change anyways when you go and review it in the future. Okay, so the next one, Math and Architectures of Deep Learning. This goes a lot more into math, not super deep, but sufficient. So for example, you will learn some proofing for, matrix multiplication, for example, just some though, not very much. But, for the purposes of coding, neural networks and using them in, say, like data analysis, this is probably the most efficient material to use. And maybe it's a little bit underrated, but let's kind of discuss that. So you can see the table of contents here. I do think that some of the later chapters really kind of skip out on the details, and that makes sense anyways, because, for example, the probability that you're going to be working on, like, say, differential manifolds for your machine learning projects is pretty low. And so maybe we just have to understand manifolds from a very conceptual level to understand, for example, like the image processing that gets portrayed in this book. Yeah, just because some of these topics just run way deeper than you can include in a single book. Anyways, so, but very good. And if you're going to read a single book on machine learning, this should probably be it. I do think this is probably much better than mathematics for machine learning because, yeah, anyways, enough said. Okay, so you see here a segment on matrix diagonalization here and using PyTorch to code it. This is a better example, I think, of how to learn Python programming from these books. And so basically we learn here is to create a function that takes a matrix parameter, and then the rest of this is all based on just the mathematics for creating a diagonalized matrix, or the diagonalization of the matrix. So for example, here we use the new matrix A1 is equal to the matrix multiplication function taken from Torch, and then we add our matrices here that just follows this formula, right? So we have the eigenvector matrices. This is the inverse eigenvector matrix with the covariance matrix or the diagonal matrix here. So it's useful for seeing how some of the math gets portrayed in the code, but yeah. And now this is a segment on the math, and like I said, I think this is sufficient to do the work and the code, but it's not as deep as it could be, but it's sufficient to do the work. So yeah, there you have it. I guess I should also say the math is largely computational, so there's not really anything in here that's like that difficult. It's mostly computational, so it might take some time, but you can probably get through it. Okay, so next one, how to prove it, from Daniel Velleman. Arguably this should have its own video, but this isn't a math channel, so yeah, I don't think I can justify that, unfortunately. Okay, so let's go into it, and let's talk a little bit about its relevance to like machine learning, for example, and why you would want to know how to do stuff like this. So once you move past like the very basics of like computational linear algebra, for example, linear algebra is, by the way, very important to like all manner of things, frankly, but one of them being statistics, and therefore machine learning. So a lot of linear algebra, though, eventually, especially as you move away from like finite dimensions, for sure, becomes abstract, or you abstract away a lot of the computational aspects, which means you're going to need proofs. So yeah, that's certainly one case to be made for this. Now, Daniel Velleman's book on proofs is certainly going to, I think if you go through this for the first time, it should be pretty Definitely manageable for somebody that hasn't taken any proofs on courses on proofs. I think for sure it's not very difficult to go through. The problems seem very gradual in presentation. My only concern with the book is that sometimes it's a little bit wordy. So namely in its explanations of why proofs work, especially in the logic section, feel just very wordy to me. And maybe you won't experience that problem. But aside from that, it's a very good book for learning how to prove things. Yeah. So, for example, these sections on logic, other comparable books like take, Tao's analysis or, really like any intro analysis or like abstract linear algebra books. They all have, intros to logic and set theory in there, for example, right? This book is going to dig much deeper into that and how the different methods for proofs can be used. I also think you'll get a lot more practice with those using this. So, for example, there are sections dedicated to using contrapositives to, showcase that an argument is, or that a certain premise, a certain conclusion can be made. So, you get dedicated sections to each problem-solving method. So, contrapositives, for example, another one is counter arguments, or argument by contradiction. Sorry. Yeah. So, and then these are just some solve questions that you can take a look at if you want. Yeah. Okay. Last one. I think this is the last one. Discrete Mathematics from Shams. So Shams series is a little bit hit or miss. This is definitely one of the better ones, though. I actually really like this one. This is probably, in terms of quality, along the lines of their linear algebra book, which I think suffers from the same problems, but has the same advantages. So what's nice about this book? Well, it goes through things very quickly and gives you enough that you can understand and learn the subject for a first time, which is not always the case with some of these books. So, for example, the probability and stochastic processes book, or maybe that's like random variables and stochastic processes. That might be the title, whatever. I don't like that book, so it doesn't matter. That one, I don't think it's very easy to learn, for example, like Markov chains for the first time from that book. I don't think it's very easy. This one, though, is pretty easy to follow. The only problem is that you can only really use this maybe as like a first exposure to the subject because the questions are too easy. And the same thing with the linear algebra book, right? So, fleshed out enough that you can understand the subject. Just, you can see all the content in here, by the way. It does cover a lot of stuff. So it is a pretty great first exposure to discrete math. But again, just the questions are like, you might not feel this way on the first time, but when you revisit the book, the questions are very easy. So anyways, we're going to showcase a couple sections from graph theory. So you can just kind of look at that and, you can see, like, this isn't point, formula, like some of the other books are. And I don't think there's really a lot of sections in here that overstay their welcome with the verbosity. So, yeah. Cool. And this is one of the questions from graph theory. So anyways, you see what I mean, though? Like, I mean, these are pretty easy questions, you know. So we take this matrix, and you see that it maps to this one. Yeah. Cool. And this is also lattices. So the reason I chose this because the other page has a lot of English, not a lot of math. So right here, you can see that these are the three properties satisfied by a partial order relation. Yeah. So I think that the explanations here are pretty clear. It's, you know, you get the three properties, you get what those three properties defined, the notation for them, and then differences between, say, like strict relations and partial orders. Yeah. Sorry, not like strict, but just total orders, usual orders. Yeah. Okay. Anyways, so that's that. I guess, you know, just very briefly in summary, the Discrete Math books from Shams is pretty good. Daniel Velleman's Proof book is pretty good. The Math and Architectures for Deep Learning is pretty good, and I think those are all standalones that you can read and maybe should read if you are trying to get into machine learning / deep learning. The one from whatever the cookbook, I would say just ignore that. I've unfortunately read maybe like 2 or 3 cookbooks now. I don't like any of them. Just don't. I wouldn't say that. They just don't seem very useful. Okay, so if you liked the video, then please like and subscribe, and all right, bye.